With these circuits, these are crazy circuits where you're combining now all sorts of parallel and series and trying to find the total voltage, the total currents, and the total resistances across each of them. What becomes really important is that you have enough space to draw lots of pictures, because every time we put together resistors, we're going to draw a new picture. And so those pictures will end up helping you make sure you have a lot of blank space. So whenever I look at this one here, I have the battery down here with a total voltage, then that's in parallel with this, which is in parallel with all of these guys, but this guy is in series with these two that are in parallel. So when I look, usually I'm going to look as far away from the battery as I can and find something that's a really easy series or a really easy parallel. And when I look at it, I can see these two here are the ones that I'm going to look at to put together first. So before I do that, let's label these. This has an ohmage of 10, R2 has an ohm value of 30, R3 has an ohm value of 20, and R4 has an ohm value of 40. So when I go to put these two together, remember that they are in parallel with each other. So I'm going to redraw this. I'm going to have, here's my R1, which is 10 ohms, and then over here I'm going to put those together, and that's going to have an R2, 3 value, which is the two of them together. Now remember that when I add those together, because they're in parallel, I'm going to have 1 over 30 plus 1 over 20, and then I'm going to flip it. That's my 1 over R2, 3. So 1 over R2, 3, when I do that, I end up with a value of 12 ohms. So I'm going to label this to be 12 ohms. Now remember that I still have this 41 down here, I just didn't draw it. And when I look at it, the next thing I would say is, oh, well, these two here are very easy to combine. So what I could do is take and combine them together into a resistor that I would call R1 to 3, or R1 to 3. And then underneath that, remember, I'm going to have a resistor that is my R4 value that is 40. So how do I find the equivalent resistance of resistors that are in series? Remember that we just add them up. So 1, 2, 3, R is going to be 10 plus 12, which is going to give me 22 ohms of resistance. Then the very last one is I have these two that are in parallel with each other, so I'm going to put them together into a resistor that is R1 through 4, which is also my total resistance because it's all 4 of the resistors, and then connected down here to the battery that we know has a voltage of 30. So again, because these are in parallel, I'm going to take and do RT. 1 over RT is 1 over 22 plus 1 over 40. And when I do that, I get an RT value of 14.19. So this is equal to 14.19. Now, interestingly enough, I know the voltage of this battery, and I can start working now that I found my total voltage, my total resistance. Then can't I find my total current? So I can take 30 divided by 14.19, and I'm going to try putting this into a different color here. So I'm going to take 30 divided by the 14.19, and that's going to give me 2.114 amps. So now that I have the totals for all of them, I can fill in my table over here. My total resistance is 14.19 ohms. My total current is 2.114 amps. Working back from that, well, since this was a parallel circuit, remember that in parallel we have PVC, parallel voltage constant. So what we're going to do is say I can describe each one of these with a voltage and a current, VI and R, a V123, an I123. And since my voltage was constant, my voltage here was 30. That means each of these have to be 30 also. Then I can use the math, VIR, V equals I times R, or Ohm's law. to find out what each of the currents are. So this current, when I divide those, I get 1.36 amps. And when I divide these two, I get 0.75 amps. Now the beauty with these problems are I can also look at a parallel circuit and say, hey, isn't my current, doesn't it add up? So if I add these two values, then they should equal this value. And if you throw those in your calculator, they do. They come out very close to that. And the only difference is because of the rounding that I've been doing going through it. So when you look at that, now I have my 4 value. I can take and label my 4 down here. My current was 0.75 and my voltage was 30 volts and amps appropriately. Now I want to take this guy and unpack it back to these two. So I'm going to take and say, well, there is an R1, there's an I1 and a V1. There's an R23, an I23, and a V23. And if I'm coming from here to here, this was a series circuit, and remember it's SCC, series current constant. So this current that I found, the 1.36, that's going to be the current for both of them, 1.36 amps, 1.36 amps. And again, to find the voltage then, I can use Ohm's law, V equals IR. When I use Ohm's law to find that, that's going to give me a voltage here of 16.32 and a voltage for V1 of 13.6. And again, remember in a series circuit, what do you know about the voltages? They add up, so I should be able to add those two voltages up and get roughly 30, and you do, you get about 29.9. Again, differences because of rounding, but that helps to prove that you're on the right track. So from that then, don't we know what all of our 1 values are? So we can fill in voltage 1 over here, 13.6 volts, and current 1, 1.36 amps for our first resistor. Then the very last one is we have to unpack our 2-3 guy and put it into the 2 and 3 by itself. So to do that, we're going back to a parallel circuit, which is a parallel voltage constant. So I'm going to have an I3, a V3, an I2, and a V2. And again, in a parallel circuit, our voltage is constant, and we're unpacking the 2-3, which means both of our voltages have to be 16.32. And then use Ohm's law in order to calculate what each of the amperages are, and you should get an amperage of 0.544 amps for I3 and an amperage of 0.816 amps for I2. And again, remember, for a parallel circuit, we add our currents up, and that will give us our total current, the 1.36, and you do add those, and they are very close. So now we have finished 3 and 2, and we can fill both of those in on the table. 16.32 volts, 0.816 amps, 16.32 volts, and 0.544 amps. So notice that drawing our pictures every time we collapse a resistor becomes very important, and then each resistor value has a VI and an R, and we can find those based on a combination of Ohm's law, V equals IR, and our SCC PVC, and we're just alternating. In one we're unpacking parallel circuits, and the next we're unpacking series, and the next we're unpacking parallel. And then the easiest way to fill in your table is not to do the table, but to actually do all of your pictures first, and then fill your table in from that.